yet. I'm not sure that you can, but if you can hear us, hello everyone, and welcome to our C8 mock test live solve. We hope you're excited to be here. I know I am.
Yay! Alrighty. Wow, so many people in the chat. I think you guys have figured out the
Hmm.
chat relay thing, which is so awesome. If you haven't, you can go ahead and just send any message, and then it should show up on our screen. And if you send cool messages or helpful math messages, then we will give you guys stars. I think a lot of you guys have figured out the idea of stars, but they can get pretty crazy.
Okay. I don't know if that's a problem on my end or your end, but I could barely hear what you were saying.
Oh
So
no.
let me check my setup for a second. But otherwise, let me just see. Can anyone else hear what Sam was saying? I'm not sure, but looks like
Okay, I
people can hear
think
me at least.
yes.
Yeah, it says some people are
Oh,
saying
someone said
barely, or
barely.
some people are saying I can't. Okay, so maybe
Oh
it's on my
no.
end,
Okay.
but otherwise, hello everyone, welcome to the live solve, and I will check out that. Maybe Sam can introduce me while I'm troubleshooting my own issues here.
Yeah.
Uh,
Okay, so Eli is a super duper awesome teacher. I'm so excited to be teaching with him today. But just briefly going over some of his things, his math things. So Eli is actually a college student. He's originally from Connecticut, and he's an Amy qualifier, and he does a lot of fun math things. He's been teaching for a while now, so really lucky to be with him here. He was a US presidential scholar and he also plays marimba in his free time. So definitely a very cool person.
okay, I can hear you, Sam. Thank you for that awesome introduction that I was able to
Yay!
hear the end of. And hello everyone, I am Eli. I'm excited to be here. Now I'll go introduce my co-teacher, Sam, who has all of her ducks in a row because I don't know what was going on with my headphones, but I think I'm okay now. Sam has qualified for the AIME since 8th grade and actually placed second at mathleague.org nationals, which is a really awesome accomplishment. And outside of math, Sam also enjoys cooking, listening to classic rock, and exploring nature. So everyone, please welcome my co-teacher, Sam Kofi.
Yay! Thank you so much for that warm welcome, Eli. That was super duper awesome. Okay. I think we should just jump straight into the math because I think a lot of people are really excited about this.
Yeah, sounds good. Okay, let's take it away. Maybe I can take the first problem.
That
So
sounds good to me.
this is number one from the mock exam. What is the largest prime number less than 71? Okay, well, it sounds like this is just a listing prime numbers thing, but I see some hints that maybe some people know what this answer is already, and it might be a really famous number. But okay, I think instead of going forward from like 2, 3, 5, and so on, we could actually go backwards. We could say, okay, something less than 71. 70, is that prime? No, it's not. Let's see, 69, is that prime? Well, it's divisible by 3, right? This is 3 times 23. So I don't think that is a prime number. 68 is even, so it's definitely not. And then finally, we're left with 67. Okay, and 67, let's just check in our heads. It's not divisible by 2 because it's odd. It's not divisible by 3 because actually this was divisible by 3 and this is 2 less. It's not divisible by 5 because it ends in a 7, not a 0 or a 5. And it's not divisible by 7 because if this was divisible by 7, then this minus 7 would be divisible by 7, which is 60. And 60 is 6 times 10, not divisible by 7. And so actually after this, we're done because we've checked the primes from 2, 3, 5, and 7. And the only prime after that is 11. Well, not the only prime, but the next prime after that is 11. And so if this was divisible by anything, if this was divisible by 11, well, it's not divisible by anything here. And so it would have to be something 11 times a bigger prime, right? 11 times something else, but then it would be too big because it's only 67. 11 squared is 121, which is already bigger. So that's how we know that this is not a prime because it's not divisible by these four prime numbers here. And so, as everyone is saying in the chat, the answer is in fact 67, which looks to be option E. Let's see. Is this the correct answer, though? I mean, maybe everyone's wrong. Doesn't seem
It's
like that's the
actually
case.
67.
It is.
Yay! Good to see we
All right.
can get this first problem right. Alrighty. Okay, let's go on to the second one. Okay, so we have Karen who is going into a building. Uh-oh. which has one floor, and then she kind of goes to the stairwell and she climbs up 6 stories, and then she walks into an elevator, and then she goes up 7 more stories. And each story is 4 meters high. So we want to figure out Karen is 2 meters tall. How many meters above the ground are the bottoms of her feet? What a wonky question. Okay, let's take a look. I think we kind of need some kind of diagram or way to organize all this information because I feel like there's so much going on here. So we're starting off. We have the ground level. So I'm just going to draw like the ground level down here as a line. Okay, Karen goes up to floor 1. Okay, so this is floor 1. And she climbs up 6 stories. So we're going to say she goes up 6 stories. 6 stories. Okay, awesome. And then she goes into an elevator and goes up 7 more stories. So 7 stories. So at this point, I think she's on the 13th or the 14th floor. Yeah, 14th floor. Okay, floor 14. And each story of the building is 14 meters, 4 meters high. Good lord. Okay, 4 meters high. So if she's 13 stories above the ground, and each story is 4 meters high, we can say that Karen is 13 times 4 equals 52 feet above the ground. And this sentence where it says Karen is 2 meters tall, I don't think that means anything because we want to know how far the bottom of her feet are from the ground. And so Karen's height has nothing to do with that because the bottom of her feet is where the height, is where we want to figure it out. So Karen's height doesn't tell us anything in this problem. And so when we figured out 13 times 4 is equal to 52, that's it. I think that's our final answer. What do you think, Eli?
Ooh, it's C, and the answer's not 67, which is E. I mean,
Oh,
I don't know.
wait a
I don't know.
minute.
Can we trust this? But I think I like your reasoning anyway. So let's see. Wow, we see that it is C. It is 52. Awesome.
Amazing.
Okay. Nice job, Sam. And on to the next question, which is number 3. Okay,
Awesome.
so each small square in this picture has side length of 2 units. What is the number of square units in the total shaded area? Okay, so I think there's a few ways you could go about this. You could actually go and measure everything out just using all the twos. But another way that is kind of fun in this kind of problem is to realize that, well, okay, I know that everything is just going to be multiplied by 2 at the end, and we're talking about area. So we just multiply by 4, which is 2 times 2, instead of dealing with any, like just all the twos in the diagram in the first place. So what you could do actually is just say that everything is 1 and then multiply by 4 at the end. And since that's kind of cool, I'm just going to do that. So what is the number of square units in the total shaded area? Okay, so we can just start labeling. This is 1, 1, 1, 1, 1. Looks like that's 5. And then, so this is going to contribute 5 times 1 is 5. So that's how much is in that, say, yellow area there. And then we have some stuff over here. So let's see, that's 3, right? 3, and this is 4. Okay, so that's going to be 4 there. We can go up here. That's going to be 2, 3, 4, 5. It's another 5. And then finally, the last one over here will be 1, 2, 3, 4. And so just split it up this way. We have 5 plus 5 is 10, plus 4 plus 4 is 18. Now we take 18, we multiply the 18 by 4, and we get something. Let's see, 40 plus 32 is 72, I think. And so that looks like option E to me. Again, it's not 67, which makes me concerned, but I don't know. Sam, do you think this is the right answer?
I like where you're going with this, Eli. I feel like this is some pretty good intuition. So I think this might be right, especially since the last one had 67, but 67 wasn't the right answer again. All right, well, let's take a look.
I got it.
Okay, and we are right once again. It is 72. Okay, amazing. All right, let's move on to question number 4 now. Okay, so when we're driving a car, the rule of thumb is that you should stay at least 2 seconds behind the car in front. That means that at any particular road sign, the duration between when the back bumper of the car in front of you passes that sign and the front bumper of your car passes that sign is at least 2 seconds. So if you're driving at 60 miles per hour, how many feet long is that 2-second distance? Okay, I feel like we have a lot of extraneous information here, meaning there's a lot of irrelevant stuff that we don't really care about. Like, I honestly think this entire first paragraph that I read is like not relevant. I mean, if you're interested in driving, like that's probably pretty important, but for me, no. I'm trying to do some math here. So, we're driving at 60 miles per hour. I'm going to write that as 60 miles, which I'm going to abbreviate as MI, and then divided by 1 hour. So that's my speed. And I want to figure out how many feet are in that 2 second distance. So I need to take 2 seconds of this distance. Now, I can't just multiply by 2 seconds because there's no seconds anywhere in 60 miles per hour. I need to convert this hour at least to some kind of second. I need to convert that time into seconds. So how I'm going to do that is first I'm going to go to minutes. I know in 1 hour there are 60 minutes. So I'm going to go ahead and do that first. And in 1 minute, there are 60 seconds. So I'm going to go 1 minute, 60 seconds. Okay, and now I can go ahead and multiply by those 2 seconds from before. And actually, let me go ahead and move some of this down so that way my face is not blocked, because that's kind of sad. Okay, here we go. Alrighty, and now what we want to see here is if we go ahead and like cancel some stuff out before we multiply anything, we'll see the hours cancel out, the minutes cancel out, seconds cancel out, and then we're left with miles, which is good, like that's a distance. But the thing is, the question asks us about feet. So we also need to convert feet into miles. Thankfully, if you don't know if you don't know that off the top of your head, which is totally okay, it's given to you here. There are 5,280 feet in 1 mile. So we're going to go ahead and multiply by that ratio as well. So we'll go 1 mile in the denominator and 5,280 feet in the numerator. So if we go ahead and multiply all of this together, I see that there are some 60s that'll cancel out. And so we're left with 2 times 5280 divided by 60. And if we go ahead and simplify that, I can see a 10 goes out, 2 over 6. I see a 3 in the denominator. I get 528 divided by 3, which is going to come out to be 176. 176? What do we think?
Yeah, I think I got the same answer. So let's see if
Amazing.
an option A is correct. And hey, it is. A, it's pretty cool. Okay.
Yay.
On to question number 5 now. Thank you, Sam. Oh, it's another paragraph long one. Oh man.
Oh my
Okay.
goodness.
This is just reading comprehension now. At exactly 9 o'clock, a 7-person charity relay starts. Each person takes exactly 4 minutes to run 1 lap. Okay, so there's 7 people. It starts at 9, and each person takes 4 minutes to run a lap. Great. At that moment, the referee shouts 1, and the first person runs 1 lap around the course. As soon as the first person finishes, 2 is said, and then the second person runs 2 laps. He continues in this way, shouting 3, 4, 5, 6, and 7. But when the referee shouts 7, the crowd explodes and yells 6, 7. So what is the time when the referee shouts 7? Okay, so this doesn't seem that bad. It looks like we're just going to have to add up a bunch of stuff. So we start at 9. That's just going to give us a reference point so we can actually find a time. But we just want to find how long it takes to get there. So, well, we know that it takes 4 minutes to run 1 lap. So the first lap that's run takes 4 minutes. And then the second lap, well, the second person, I mean, runs 2 laps. So that takes 4 times 2, assuming, I guess, they're not getting fatigued or anything. And then the third one is 4 times 3 because they run 3 laps. And then 4 times 4, 4 times 5, and 4 times 6. And then at this point, after the sixth person has run the 4 or the 6 laps, that is when the referee shouts 7. So I don't think we have to add 4 times 7. Maybe that's like a little trick in this problem that you might get caught on. But we don't have to add 4 times 7. All we have to do is evaluate this. And you could just add up everything. That would work. But it's kind of cool to try it a different way. And that's to notice that, well, first of all, we have all these 4s here. We can factor that out. And what we're left with is just 1 plus 2 all the way up to 6. And, okay, I don't know if I should explain where this comes from. Sure, I can do that. Yeah, this is fine. There's a formula that's really cool for evaluating a sum like this. And the way that you get it is by saying, well, I'm just going to pair things up, right? I have 1 and 6. That's cool. And I know 1 plus 6 is 7. Now I also know 2 plus 5 is 7. And 3 plus 4 is 7. And hey, look at that. We have 1, 2, 3, 4, 5, 6. But I've paired them up in a way that I just have 3 7s. And so actually this sum is just the same thing as 3 times 7 because we can pair up the numbers in this way. And so we get 4 times 3 times 7, or 4 times 21, which is just 84, I think. Well, wait. 4 times 21. Yeah, that's right, 84.
Yes.
Okay,
Yeah.
so 84 plus 9 o'clock. Okay, well, we have to say that this is 60 plus 24, and so I think it would be 10:24 is the final time. Option E. Okay, that was a lot of math. Let's see.
Let's take a look.
Hey, it was right. Cool.
Amazing. All
Oh,
right, wonderful job, Eli. Okay,
thank you.
let's go ahead to question number 6. Oh, yay, no paragraph. This is awesome. Okay, so we want to figure out how many positive integers are factors of 2026. All right, I feel like on every math competition, there's always a question involving the year. So let's go ahead, take a look at the factorization of 2026. I'm going to go ahead and start by noticing that obviously this is even, so let's go ahead and divide by 2 first. All right, then we get 1013. This is interesting. Off the top of my head, I don't see any clear factors. Obviously, it's odd, so it's not divisible by 2. It's not divisible by 3 because the sum of the digits is 5. It's not divisible by 5 because the last digit is not 0 or 5. Let's see if it's divisible by 7. Well, I know 1001 is divisible by 7, and so if I add 7 to that, 1008 would be divisible by 7. But then if I add 7 to that, that's 1015. So I don't think 1013 is divisible by 7 either. What about 11? I don't think 1013 is divisible by 11 because if we look at or actually 1001 is also divisible by 11. And if we add 11 to that, that's 1012 is the next number divisible by 11. So obviously that's not 1013. That's not going to work. If we look at 13, 1001 is again divisible by 13. So really cool fact, 1001 is equal to, oh no, okay, here we go. 1001 is equal to 7 times 11 times 13. Really, really big, important fact. You don't know. Okay, well anyways, 1001 is divisible by 13. If I add a 13 to that, I get 1014, which is not 1013. So obviously this number is not divisible by 13. All right, well, maybe we can look at the next prime factor, which is 17. I don't know any cool trick to help me with this 17, so
Yeah,
I might
I
just,
think this is going to take a long time if you
yeah,
don't just happen to know this fact that 1013 is prime.
yeah,
Um, yeah, so okay, you have to know that fact because otherwise this is going to take a really long time. We would
yes.
go to
Otherwise, you're gonna have to
17,
check every
19.
single factor.
Yeah, and you can do the same trick that we did before, but then you'd
Mhm.
still have to go up to like 31 or something.
Yes, I
Probably,
think
yeah,
like,
yeah.
yeah, 31. Yeah.
Yeah, so that's like just not fun, and you can do that at home if you want. That'll be fun for you.
But
But
we're
I
gonna tell
think,
you 1013 is
yeah,
prime. I do want to emphasize this fact though, because this is super cool. But yeah, we don't have to go until 17 or up until 31 because that's a lot of work. So yeah, 1013 is prime, and if that's prime, well, there's no other factorizations, right? So our only factors are going to be 2, 1013, and then 1 in 2026 as well. So that's just 4 factors of this number. So answer choice C.
all right, let's see if that's correct. And hey, I see that it is. Awesome job,
Yay!
Sam. And I think we're ready for 7. Look at that, we went from 6 to 7. Happens. What can I say? Okay. And it's another super long one, so here we go. Gotta
Oh gosh, Eli, you
browse
always
in.
get these long ones.
This is the Google Search Trend report for 67. Google's report doesn't tell what units the y-axis is measured in, but the y-axis is drawn to scale. So it is clear that the internet's interest in 67 was relatively stable for a long period of time, yeah, and then spiked recently due to some meme. If you do not know why anyone would be interested in 67, consider yourself lucky because in many parts of the world, whenever the numbers 6 and 7 come up, the whole classroom explodes with everyone screaming those numbers. The more you know. Okay, at the end of the year, 2025, the rightmost tip of this plot, which of these ratios is closest to the ratio of people searching for 67 because of the meme versus whatever people were searching for before the meme? Okay, so we want to find the ratio between this point, I guess, like right at the top, and whatever this was before. I guess that's like at this point, like this kind of thing. Am I interpreting this correctly? I think so.
I think that's correct.
And so we can see that this was at 100, and this is at something. Okay, I'll zoom in a bit here. So we have, this is definitely 100, which is great. And we don't even care what the units are because we're looking at a ratio. For this, we just have to like squint and imagine. I feel like this is about maybe a fifth of the way to 20.
Yeah,
So maybe
I
this is
would
like
say that's like
4.
maybe 4 or 5.
It seems to me like around 4. So
Before?
let's
Okay.
say it's 4. I think so, yeah. Around. So a ratio I think would be 100 over 4, which is like 25 to 1. And if we look at our answer choices, okay, well, none of them are exactly that, but 20 to 1 seems pretty close. So I'm going to go with option D. This is really just a squinting and hoping that you get close numbers exercise, I guess.
Yes.
So I hope it's close, but I think none of the other ones are really that close
Close
to
enough. Yeah.
this ratio. So
Yes. So
let's go
whether
with
you think
D.
it's 4 or 5, maybe even 6, I think would be okay. I think you'll get close enough to D. So let's see if that's right. Oh, that was
Looks
anticlimactic
like
on
it
my
is.
end. Okay, yay! Yes, it is
Yay.
D. Amazing. Thank you, Eli, for working through yet another paragraph problem. All right, let's take a look at question number 8. Oh, I'm so lucky. I got all the short, tiny ones. They're easy to read for me. Okay, so we have a strange country which only has 6-cent coins and 7-cent coins. And we want to figure out how many different ways are there to make exactly 67 cents out of these coins. Alrighty, let's take a look. I mean, off the top of my head, I can immediately see that. Well, actually, before I do anything crazy, I'm going to set up a table. I really like tables. So here's my 6-cent, here's my 7-cent, and here's my little table. Okay, off the top of my head, I can immediately see that if I use one 7-cent coin and 10 6-cent coins, that's going to get me to 67, which is great. Now, I need to figure out how can I make more combinations of these? Well, I know that if I have 7 6-cent coins, that's going to be the same as having 6 7-cent coins. So I'm thinking I can do a little bit of replacement here. Instead of having maybe 10-cent 6-cent coins, I can maybe only have 3. So if I have 3 6-cent coins, the 7 6-cent coins will turn into 6 7-cent coins, meaning I'll have 7 7-cent coins instead of just 1. Sorry, that was a real tongue twister, but if we want to check the math, that's going to be 6 times 3 plus 7 times 7, which comes out to 67. So this is correct. Now, if I want to do the same replacement thing again, I need 7 6-cent coins to translate into 6 7-cent coins, but I only have 3 here, so it's simply not possible for me to get more 6 or more combinations. So these are going to be my only 2 combinations. That gives us answer choice C. Let's take a
Yeah, that
look.
was an awesome explanation, Sam. And it looks like you got the right answer.
Yay!
Okay,
Awesome. All right.
fantastic. So now we're on to number 9. And, well, it's a fairly long problem, but it's not the worst thing in the world. We have a weird die. That's fun. It has the numbers 1, 2, 3, 4, 5, 6 in a non-standard arrangement. So, okay, this is a fun fact. If you know this about dies or dice, every opposite side of dice will add up to 7. So, like 1 and 6 will be on opposite sides, and 3 and 4, and so on. But it looks like that's not the case here. Maybe. I actually can't really tell. Yeah, 1 and 6 are definitely not on opposite sides here because these are actually adjacent. So this is a non-standard die. I'm playing a strange game where I roll the die, and the score I get is the sum of the number on the top and on the bottom. Okay, so that's why that's important, because that
Yeah.
would always be 7 with a normal die, but in this die, it could be anything. There are 3 possible pairs of faces that you might sum together. What is the average of those 3 sums? Okay, so I think this is just an exercise in building a cube in our minds based on this
Yes.
diagram here. So if we say that this is like the bottom face or something, we fold over this, we fold over this, and we fold over this. I see that 1 and 2 are on opposite sides. And I'm celebrating that with balloons, apparently. So, because Zoom
So
has, I
many
guess,
balloons.
it has the balloon thing if you hold up a 2. So it's just going to keep
Oh, I
happening, but
didn't know that.
it's
That's weird.
okay.
Okay, wait, I'm not gonna do that. I'm kind of scared.
Maybe I'll use 2 different fingers. Okay, so we have 1 and 2 on opposite sides. That's great. Their sum is, of course, 3. Okay, then what is the next pair we have? Let's see. If I fold this over and then fold it again, it looks like 4 and 6 will be on opposite sides.
Yes, I think I agree with that.
And so I believe we get 10. I'm wondering if we even need to do this because don't we just take the sum of all of them and then
Yeah.
divide by 3?
I was gonna say
Yeah.
that, but I thought it would be fun to like watch you make the cube.
Yeah, well, whatever. Okay, so I'll finish doing it because it's kind of cool. Okay, the only other two sides are 3 and 5, so it would be 3 and 5, and then we'd get 8. And so we didn't need to do that, but whatever. Then we could take these three and add them together. We'd get 21, and so we'd get 21 over 3 is the average of 7. But as Sam has noticed, another way we could do this is to say, well, it doesn't really matter how they're paired up at all. All we're going to do when we find this average is sum up all of the faces and then divide by 3. And so we would just do 1 all the way up to 6 and then divide by 3. And we would get, well, actually, we evaluated this earlier and we got 21. So that would be 21
Yes.
over 3, which is 7. And that's option E. Okay, let's
Yay.
see. Thank
I
you,
did see,
Sam, for the,
of course, yeah.
yeah.
I did see a couple people saying option A. Remember, we're looking at pairs of sums, not the average of all the numbers. So that's why E is correct and not A.
Okay, looks like you're right. E is the correct answer. And now, Sam, take it away with the next one.
Alrighty. Okay, so we have the average of nine two-digit numbers with tens digit 6 is 65. Which number is not one of them? Oh, okay. I was like, I felt like I was misreading the problem. So we have nine two-digit numbers with tens digit 6. Okay, so first of all, the number of two-digit numbers with tens digit 6 starts from 60 and goes up to 69. So there are actually 10 numbers like this. So 10 numbers. And we're told the average of 9 of them is 65. And so if we go ahead and do like, okay, I'm like hesitant on whether or not I want to do this. Okay, I guess, I guess we can look at, hmm, I'm a little hesitant about doing this calculation. I feel like there's a smarter way to do this. My intuition is like, okay, let's go ahead and find the sum, but these are kind of like big numbers and I don't really want to find the sum. So, you know what? Here's what I'm going to do. I know my average is 65. So what I'm going to look at is I'm going to look at the differences from all the numbers from 65 and maybe see how I can balance this out. So, if I start from maybe 60, the difference from 60 to 65 is going to be -5. And then and maybe I should write 60 so it's clear like what I'm doing here. The distance from 61 to 65 is -4. And I mean, this is just basic subtraction, so I'm going to kind of speed through this. When we get to 65, the distance from 65 to 65 is 0. The distance from 66 to 65 is 1. So notice how this goes from negatives to positives. And if we keep on going, we'll see the distance from 69 to 65 is going to be 4. So in order for the average to be 65, we need all of the distances to sum to 0. Meaning, if I have like a distance of -4 and a distance of +4, that sum is going to be equal to 0. So we can say that average is going to be 65. And so I actually noticed like going from all the way from 61 to 69, all of those distances are going to sum up to 0 because they come in pairs. I've got a -4 and I've got a 4. I'm going to have a -3 and a +3. And that just kind of keeps going on. The odd one out is going to be 60, which is -5 away from 65. And that kind of throws off our averages, which is why it's not going to be part of our 9 two-digit numbers, meaning the answer should be choice A. What do you think, Eli?
Yeah, I agree with the answer. That was a really, really clever approach of doing it with looking how they differ from 65. I really would never have thought of that. I will mention that I think there are two other ways that you could go about this. One of
Yeah.
them, I think, is just doing the direct calculation is it's not like really like that bad. It's like okay, because you could do 60 times 10 to get rid of all the 60s out in
Oh,
front, and
that's
then
right.
it's like 1 plus 2 all the way up to 9, which is 45, and then minus whatever the number is equal to 65. And then you just multiply through by 9, and then you can kind of split it as 9 times 60. So then this just becomes 60, and then 9 times 5 gets rid of the 45. And so you
Yeah.
get that x is 60, which is, I think it's not terrible.
Yeah,
Um,
that's true. That's
and
true.
then I think the other way, like what was most apparent to me here is that I see 65, and like if I pair up all the numbers normally, I would get 65, right? 61 and 69 give 65, like in terms
Yeah.
of average. So if I have the 9 numbers from 61 to 69, I already know the average is going to be 65 just from experience. And so then I can know that like 60 had to be the odd one out. And
Oh,
so,
that's so
yeah,
true.
yeah,
Okay, yeah, that's actually like pretty smart and pretty fast too. Okay, that's neat. Yeah, thanks for
yeah. So
sharing those other approaches, Eli. That was super helpful.
there's a few ways of doing it, but whichever way, I believe A is still the correct answer. So let's see. Hey, looks like it is.
Amazing.
Uh,
And we triple checked that, so we knew.
of course, of course. It's always
All
great when
right.
you can do the same math problem in a bunch of different ways. Then you're pretty sure that it's right. All
Yes.
right, number 11. Alice and Bob are running around a circular track. Hey, another track problem. They start on opposite sides. Okay, so let's see. It's something like this. They're on a track, and they start on opposite sides. Let's say A and B. Of course, Alice and Bob. Alice runs clockwise. Okay, so that would be this way. And Bob runs counterclockwise. So that would be this way. Alice completes one lap every 6 minutes. So this is a 6 minute lap. And then Bob completes one lap every 7 minutes. So this is a 7 minute lap. After minutes, after how many minutes? How many times have they passed each other running in opposite directions? Okay, so seems to be a bit of a typo here. I wonder if anyone knows how many minutes it's supposed to be. Uh, Maybe we could also back into it somehow. Okay, people are saying in the chat 60 minutes. Maybe it's 67 minutes.
I
Hmm.
think. Let me see if I can maybe find what it
It's
is actually supposed
67
to say.
minutes.
Question 11, right? It should be 67 minutes. Yes.
67 minutes. Okay, great. 67 minutes. Oh, that's gonna make this fun. Okay, so how many times have they passed each other? This is a very interesting problem. You kind of have to wrap your head around it, I think. And the fact that they're on a circular track makes it even more confusing. But I guess one way I would think about this is just to like take it, I don't know, one lap at a time or something. Maybe
Hmm.
there's like a more clever way. I'm not sure if there is, but I would take it one lap at a time.
Yeah.
Maybe from the 7 minute perspective. Uh, yeah, okay. Yeah, let's go from actually from A's perspective and see what happens there. So after one lap, A has run all the way around and is back here. So that's after 6 minutes, and definitely has passed B going this way, and then B is like here-ish, coming back around, and A has already, let's see, passed there. Oh, this is so confusing.
This is
Passed
really weird.
here, and oh, it's going the other way. So passed here, and maybe it doesn't actually matter. Um, Maybe it doesn't actually matter at
I
this
feel
point in
like,
time because they will
yeah.
pass no matter what at that time. Um, but let's, I guess, just keep on thinking about this. So definitely has passed like at some point here and at some point here, and now they're restarting, and it's going to happen again at some point here and at some point here. And it's just going to keep on happening this way for every time that A runs a lap around. I think A is always going to hit B twice, except for when
Yes.
it's right at the end. So, okay, let's see. This would be 10 times that this happens, right? Because it's 10 laps around, um, plus one more. Oh, but we don't have the edge case to deal with because it's 67 minutes, which is one more than 66. So it could just be uh, two times for every lap, which would be two times like this would be 11, which would be 22. That can't be right because the biggest answer to
21 is
this
the largest. I know.
is
I was
21.
thinking the same thing, but hmm.
Yeah, I was thinking you could just be clever about this, but oh wait, you may have to
I
deal
think
with.
it might actually be 20. No, because they complete a lap, right? Hmm.
Well, there may be something with like what happens after 6 times 7 minutes, which is I don't know what 6 times 7 is.
42.
42. Yeah, because I think there could be a case where um, two of these actually overlap. Two of the you see what's going on here.
Oh,
There may be a time
okay.
when they're actually the same point,
Yeah.
um, and so I think that will probably end up happening. My guess is that it's just E. I'm sure that
I think
there's
it's 21. So we'll do like 2 times 11 and then like do one over count at 6 and 7 like after 42 minutes. So I think that's like a reasonable answer.
yeah.
Yeah.
I'm sure there must be a better, like more rigorous way of thinking about
No,
this
this
question.
is like a weird problem with like the visualization and everything. So I think this is like good intuition.
I hope so. Okay, I'm just gonna circle E and pray. Let's see. Hey, it's right. Okay.
Yay!
Fantastic.
Amazing.
Whew.
That was awesome, Eli. Oh my gosh, such
Lucky
great
break,
work.
lucky break. Okay.
Okay. Okay. I saw a lot of people predicting I was gonna get a short question, but now I have double paragraphs, so I
Oh,
guess this is
wow.
my karma. Okay, so we've got a street map of Manhattan. Oh, of a Manhattan-like city. And the vertical grid lines are avenues, so things that go this way. Oh, I guess you can't see my finger, but it's fine. I guess I can draw. Okay, so we have avenues and we have streets. So vertical is avenues, that's in blue, and horizontal is streets, that's gonna be in yellow. Street. Okay, the distance between successive streets is 1 unit, and the distance between successive avenues is 5 units. And so we have a taxi driver. Oh, wait, a taxi driver is estimating pi. Okay, that's a very interesting thing for a taxi driver to be doing. But pi, hopefully you recall, is defined to be the ratio between the circumference of a circle and its diameter. Okay, very interesting. So the problem is that the taxi driver can only drive along the streets. And so the taxi driver estimates the circumference of the circle to be the distance driven along the solid black polygon. Okay, and we want to figure out what is the ratio of the perimeter of the solid black polygon divided by the diameter of the circle. And we know that the radius of the circle is exactly 25 units. Okay, this is very, very interesting, and I fear I need a much more closer diagram, which is okay, awesome. That is on the next page. Okay, good to see. Okay, so to be clear, what the taxi driver is driving, because he can only go on like streets, which are straight lines. I'll outline this in yellow so that's a little clear, because I think the lines are kind of thin. So outlined in yellow is what the taxi driver is going along. It's a weird polygon, definitely not regular. Lots of ridges, which is why it's taking me a moment to get through everything. Okay. Alrighty, so basically we want to like find the perimeter of this polygon and compare it to the diameter, which we know is 25. Let me just double check. That's what the problem said, because I don't want to solve this wrong. Is it, oh, the radius is 25. Okay, there we go. So it's not 25. This should be 50. Okay. Alrighty, so we'll say 50. Okay, and we know, yeah, so we want to find the perimeter, and we know that streets are going to be 1 unit apart. So that means these vertical lengths are going to be 1 unit apart, and the horizontal units, these bits, are going to be 5 units apart. Okie dokie. So if we take a look at this diagram, there's a lot going on here. I think I'm gonna handle the long parts first, like these longer bits. I think that's a little easier to do. And I think maybe the best way to do them is, I think just to count. I think that's, yeah, I think I'm just gonna count. So if I go ahead and count, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. What do you think, Eli? Oh, Eli has counted 15. Okay, I missed one. Thank you so much, Eli, for putting that there. That's very helpful. All right, so I see 15 here, 15 here. And if we go ahead and look at the horizontal bits, or the long horizontal bits, that seems to be 20? Yeah, 10 in each, 20 in total. Okay, perfect. Thank you so much, Eli. Alrighty, and so then we're gonna go ahead and look at the tiny bits, which is the hard part, but thankfully there's a lot of symmetry, so hopefully this is gonna be better. Okay. I'm actually gonna zoom in just a little bit in case this is, oh wait, actually if I zoom in, I'm gonna mess up the diagram, so I'm not gonna do that. All right, well, if we go ahead and look at the smaller bits, I see 1, 2 here, I see 3 here, and I see 4 here. Is that 4 or 5? Okay, Eli counts 5, so let's go with that. I mean, at the end of the day, because there's so many different parts, I don't think one off is going to matter necessarily, but we'll see. All right, and then thankfully it goes the same way, 2, 3, 5 everywhere else. 2, 3, 5, and so we'll go ahead and finish that, and then we look at the other short horizontal bits, and those all seem to be 1 unit, which we know is just going to be 5 as the length. And so if we go ahead and add all of those pieces together, we get 15 times 2 plus 20 times 2 plus 5 plus 5 plus 5 on each of the short bits. So that's going to be 15. And those short bits occur in 4 different places. So I'm going to do 15 times 4. And then we get the short vertical bits, which is 2 plus 3 plus 5, or 10. And those also occur in 4 different places, so I'm going to do that times 4. And so in total, we get 30 plus 40 plus 60 plus 40, which sums up to 170. Is that even an answer choice?
Well,
Oh wait,
we
that's not
also have to
actually the final
divide
answer. Okay.
by 50, but I think that that may not be right anyway. I think there may be some things missing. Okay, I'll just mention what the chat has been saying, which is, yeah, to push everything out and get a square. Because what the taxi driver is doing is actually incredibly not smart whatsoever. Turns out they're not even close to approximating pi, because even if you do this like infinitely, your ratio is never going to change. And this is why. You can see what's going on here. Like in order for this entire length to be 50, every one of these vertical segments has got to add up to to 50. And then same
Ah,
thing with all the horizontal ones. So you can push out everything, and all you're going to get is this giant square, which is just a 50 by 50 square. And so, well, that's just, I don't know why I wrote it as 25 times 2, but that'll just be 50 times 4, which is 200. And so the perimeter of the whole thing will be 200, then divided by 50 gives us an answer of 4 as the ratio between the perimeter and the
yeah,
diameter. And so
that's true.
actually, like this is not even close to approximating pi, because even if you did this really, really fine, it would always be a ratio of 4, which is really weird if you think about it. This is actually like a kind of a paradox in math, that you can make something actually approximate another thing but not have the same properties. And that's actually what's going on here. In some sense, it's like infinitely pointy, and all that pointiness adds a lot of perimeter where it's not actually approximating the circle. And so anyway, you end up with this answer. I'm
Oh, that's
sorry.
so neat. Oh my gosh, that's amazing, Eli. I was like, there's gotta be a smarter way than counting this, because it's not like this image is very high resolution either. So I was like, okay, wow, wow, wow. All right, that's awesome. Thank you for so much for sharing that, Eli. Okay.
I'm sorry you had to go through the pain
Oh, it's
of counting
okay. It's
squares before I
okay.
realized what was happening. But okay, let's see. Is E the right answer? Yes, it is. Okay, awesome.
Yay!
Some teamwork here. On to question number 13. Lucky 13. Oh, it's short. That's good. Okay. Six
Yay!
integers have a median that is different from their mean. What is the smallest possible absolute value of the difference between their median and their mean? Okay, so interesting. We have six numbers, and we want to make the distance between the median and the mean as big as possible. The way I would think about doing this is to just have like a really, really, really giant numbers. Oh, it has to be as small as possible?
Small.
Oh,
Yeah, yeah, yeah.
small,
Small
small
as
as possible.
possible.
Oh, yeah, yeah. Okay, so exactly the opposite of that. We want to have like numbers that are really close together, but since they're integers, they can only be so close. So let's see here.
It's
Um,
definitely not A. I can say that right off the bat.
well, yeah, if they have a different median and mean, then the difference is certainly not zero. So that's a good point. Okay, let's see here. I mean, it certainly doesn't matter where we start, right? Because the absolute value of the difference won't have anything to do with the starting point. So let's just say that
Yeah.
our first number is zero, like our smallest number is zero. Um, what can happen after that? Well, if we want a really small difference, well, we could just make everything, it could be like 0, 0, 0, 0, and 1. That I think
Yeah.
would be pretty small, right? And so our median would be 0, but certainly our mean would not be 0. And I think this makes our median this makes our mean kind of as small as possible relative to the median. And so anyway, the difference would just be whatever the mean is, which in this case is 1/5.
I
One
think it should
fifth?
be one
Oh, one
six because
sixth.
there's
Oh
six
yeah, there's
numbers.
there's six zeros. Five zeros. Okay, here we go. Five zeros, and then we'd get 1/6. Okay, so we can certainly do at least that good. Is there any reason we can't do better? I mean, I'm trying to think if there's anything I've missed here.
Well,
Um,
if all of the numbers are, because these are integers, right? So I guess the worst possible case is like all of them are zeros. But in that case, like the mean and the median are the same, which is like not allowed. So the very best we can do is to have one of those zeros turn into a one, and that's the smallest mean we can have while keeping the median 0. So I think 1/6 should be the answer.
Yeah, actually, I think a way of rationalizing this is that whatever the mean is, it has to have a six in the denominator, right? Or something
Oh,
dividing
yeah.
six in the denominator. Because it's like something, which is a sum of stuff, divided by six, and those are
Yes.
integers, right? And so we certainly can't have a 12th in the denominator because if you're taking something with over six and then subtracting another integer, right, which you're subtracting the median, well, you're not going to have a 12 in the denominator and you're not going to have a 7 in the denominator. So it has to be D. In fact, the smallest number that has a 6 in the denominator is 1/6. So it has to be 1/6. It's one way of
Yay.
thinking
That's
about it.
good intuition to double check.
Okay. Hey, we're
And
right.
we are right.
Awesome.
Amazing.
Take it away, Sam.
All right, question number 14. Okay, so we got a honeycomb, very cool, with 10,000 hexagonal cells. Obviously, 10,000 cells are not drawn because I don't think you'd really be able to take your test then if it was. And so and these cells are arranged in 100 rows and 100 cells in each row. And so some of these cells contain bees, but no cell shares a border with more than one other cell which contains a bee. And we want to figure out the smallest possible fraction of cells that are empty. Okay, so basically what we're trying to do is we're trying to cram as many bees as possible into the cells while respecting the fact that like no cell with a bee shares a border with a cell that has another bee. So actually I'm going to use the honeycomb that I'm given here and I'm just going to go ahead and start putting some bees in and seeing what this looks like. So let's say we put a bee in this very like first cell, the very top left cell. And I'll denote that with a capital B. Okay, there we go. And so if this has a B, and I'll show which ones in yellow. Okay, that means these two cells cannot have a B. So I'm gonna go ahead and put another B down here in the bottom left. Now, if there's a B there, I can't have a B. Oh, wait, hold on. No cell shares a border. Oh, with more than one other cell. Haha, I have misread the question. Okay, let's double check this. All right, so let's say I have a B in this first top left cell. I can actually still have a B right next to it because that's the other cell which contains a B. Now that means there can be no B in the cell below them because then the cells would share, like each cell would share with more than one, which is not good. So they can share with with exactly one other cell. So two B's can be adjacent, but three cannot. Okay? Alrighty. So if I have this, I can now have a B still in the bottom left corner. Now if that's the case, I can also have a B next to that, but I can't have a B in the middle. And then I can still have a B. Oh, actually, I can't have a B at the top either. Yeah, can't have a B here. And I can't have a B here. But I can have a B at the very end. So I'm seeing 5 at least in this one. What do you think, Eli? Are you getting anything better?
Yeah, I guess I'm trying to do it a slightly different way. And I
Yeah.
think since, well, I mean, it shouldn't really matter in the end, but since we're trying to say like what is the approximate fraction, I guess one thing we could do is try to find like some block that repeats and then
Yeah.
see what happens in that block. And then, whatever happens in that block would have to be the ratio for
Yes.
the entire thing if it repeats. So I'm not quite sure exactly what block is repeating here yet. I'm still kind of thinking about it. And we may have to extend this diagram actually to see. I'm not
I
sure that
think
there's
so
enough
too.
space in this.
Yeah. Let me see actually if there is an extended diagram really quick. Um, okay. I don't. Yeah, okay. I have this nice big one, but it is not extended, so I'll go back to my regular one. Okay, so I'm gonna do this like manual extension, I guess, and see where that goes. Well, I mean, like, at least from here. Nah, I don't want to do that because this is not necessarily entirely accurate. Alrighty, so we go
Actually,
ahead
can
and
these bees even be next to each other at all? Because then doesn't this one share a border with two other cells that contain a bee? I'm still finding this wording really
I
confusing.
know it is
Um,
a little weird. So I think let's see if we put a
because
B in
this
that middle cell. Well,
I don't think you can ever have any that are adjacent because if like this one shares a border with these two cells that both contain
Yeah, that
B's,
wouldn't work.
and so actually I don't think you can ever have B's be adjacent. I think you'd have to always have, a B somewhere and then cross out everything next to it. And I don't think you can get
Every
around
cell
it.
shares a border with more than one other. Wait, I think you can have them be adjacent because it says like it doesn't share a border with more than one other cell that contains a B.
But you have
So
to look
two
at the
cells
empty
having B
cells,
can
right?
be adjacent. Sorry, what were we saying?
But the empty cell that's okay, well now I've erased it from the diagram, but imagine that there's a B here. Like
Yeah.
this cell shares a border with two other B's, and that's not allowed because it has to be at most one other cell. So it's the cell. It's not
Oh, I see
necessarily a
what
B,
you're
but it's the cell
saying.
itself. Uh,
Okay, okay, that makes sense.
and
Okay,
it's
so
even,
you're so okay. So the original way he had done this is right, meaning yeah. Okay, okay, that makes
but it's
sense.
it's even more stringent than that because I'm trying to extend this, but this is getting really annoying. Okay, it's something like this. Whatever. There's more cells, but you actually can't even have another B here. You couldn't even have
Because
another B
those
here
cells will
because
be
these
adjacent.
two, exactly. This cell will have these two B's next to it. So actually, I think the
I think that's
repeating
our
block
pattern.
is just this, and you have to place this here, and so there's actually like even more space in between the B's than
Yeah.
than you would expect.
So that means like in a group of 7 cells, the one in the middle is going to be the only one that can have a B. And so we don't even need to figure out the rest of it. I think that's the pattern that we're meant to be looking for because there's so many cells that if there's a couple here and there that might not go into a nice pretty 7 package, it's not enough to really change our fraction, meaning we can just look at this one pattern and figure out our answer. And so we're trying to figure out what fraction of cells are empty. In the picture that Eli has drawn, there are 7 cells that we're looking at. 6 of them are empty and the center one is filled, meaning that 6 over 7 of these cells are empty. So that should be answer choice E. Eli, that
Okay.
was such a great insight, such a great approach, looking for that pattern, and then also like reinterpreting the problem because like the wording was definitely a little weird here.
Yeah, I think the hardest part of this problem is understanding what it's even saying, which is not ideal, but we got through it. So let's see,
Yes.
is E our correct answer? And hey, it looks like it is. It is indeed
Yay.
6, 7, but there's a slash in between, so it's okay. We haven't ruined anything yet. Okay, on to question number 15. Oh my God, that's so many people, but luckily they're alphabetical. We have Alice,
Yay.
Bob, Charlie, Debbie, Edward, Faith, and Guy lining up from left to right to take a picture. How many ways can they do this if Alice must be somewhere to the left of Bob? Okay, so it doesn't have to be right next to Bob, but somewhere to the left. This is kind of cool. So we have, let's see, how many people? One, two, three, four, five, six, 7 people. So I'll draw 7 chairs because they're lining up. One, two, three, four, five, six, 7. And the only condition that we have is that Alice has to be to the left of Bob, right?
Yes.
Yes, that's the only condition. Well, something that's interesting to think about is if I swapped Alice and Bob, then they would go from either being with Alice on the left to Alice being on the right, or vice versa. And so there's a sort of a correspondence here where exactly half of these permutations will have Alice on the left. And so I think we just have to find the total number of permutations and divide by 2. I don't think we even have to do any like cases where Bob
Yeah,
is or anything. I think we can just skip right to the answer.
I
So
agree.
how many ways are there for 7 people to line up from left to right? Well, I think some people are even saying in the chat it's just, well, there's a fancy symbol for it, but the way you can think about it is like how many people can go in the first slot? Well, there's 7 people. And then how many people are left after that? Well, say if Alice sat there, then there's only 6 people left. So 6, and then times 5, times 4, and so on, all the way down to 1 to get the total number of possibilities. Once you're at this last chair, like 6 other people have already sat down, there's only one person left. Okay, so this is also, fancily written as 7 factorial. You're just really excited about the number 7, so you put an exclamation point after it. And so we know that this is what we have, but now we have to divide the whole thing by 2. And so, okay, well, what does that amount to? We just get rid of that 2 there. And now we have to compute this whole thing. Uh, I mean, 7 factorial, do I just
It's
remember what that
5040.
is? 50, 40. Okay, I'll take your word for it. And then we just divide that by 2, and we get 25, 20. And I believe that's option D. Oh, a nice quick one. Let's see if D
Yes.
is correct. Hey, it is.
Yay!
Cool.
Amazing. Okay, let's go ahead on to question 16. All right, so we are walking on a grid. Very nice. I like to walk on grids because that's super realistic. So we're starting at the origin, 0, 0, and we take exactly 67 steps. What a surprise. Each step is exactly 1 unit up, down, left, or right. And we want to figure out how many possible ending locations are there. Okay, this is very interesting. So basically, we start on this grid. And actually, I guess I'll have to draw all 4 quadrants because we can go in every single direction. And so we're starting at the origin, which I'll show in pink. Yeah, okay, here we go. So I'll show this in pink. And okay, okay. So we can either go up, down, left, or right. This is kind of weird because if I go like 1 unit to the left and then I go 1 unit back to the right, I'm exactly where I started. So this is a very weird kind of problem, I would say. And so I think there's maybe a couple of different ways I would look at this. The first is to figure out like how many steps could I take going up, down, or like left, right. So I guess like maybe we're looking more at like extremes, I want to say. Um, Okay, sorry, there's a lot going on. Okay, so I guess like the biggest extreme is we go 67 steps up. And so I'm going to show that in yellow. So that's one potential location up here. We go 67 steps up, that'll be 67, 0. Another potential location is we go 67 steps to the right. So that'll be 67. Or hold on, I wrote something wrong somewhere. This y coordinate should be 0, 67, not 67, 0. My bad, guys. Okay, and then we'll go down, and that'll be 0, negative 67. And then if we go 67 steps to the left, that's another potential option, which is negative 67, 0. And so basically, I can go to any point that is kind of like on these borders, I think. Is that... Yes. Okay. So if I like maybe connect these lines, I think I should do this in a different color. Da-da-da. Okay. Go ahead and do this differently. So basically, I can go to any point that's within these grid lines and then is also like within the square itself. But the important part is I can only step on coordinates that have integer values because I'm only taking an integer number of steps. So I can't be at like 65.4 or something. Like I have to be at like 65 itself. So I'm looking at what we call lattice points. So I need to figure out how many lattice points are bounded by this square that we have. Okay, and so if we go ahead and take a look at this, I think the best part is probably just to go ahead and find area. Because if you notice, like the lattice stuff that we're looking at is really just bounding like little unit squares within our rectangle. And so what I'm going to do is I'm going to go ahead and find a side length. That's easy to do because I know I see a little right triangle here, and it happens to be that each of their legs is 67. So the side length I'm looking at is 67 times the square root of 2. And if I go ahead and square that, I get the total number of lattice points, I'd say, inside that rectangle. So 67 square root 2 whole squared. And let's take a look. That's going to be 67 squared times 2. I feel like that's a little big. I feel like I also don't want to calculate that. I also feel like there's no answer within that realm, so I've definitely done something wrong. Alrighty, let me take a look.
I think
Hmm.
there's actually one really, really interesting nuance here. And
Yes.
I'll just ask it as a question. Can you actually get to the origin after 67 steps?
Oh, that's a good point, Eli. Okay, I see where I went wrong.
And I mean, you're basically exactly correct, and this is exactly what I did as well. And I did actually calculate it. 67 squared is 4489, I think, which is
Yes.
one of the answer choices. And at this point, you could probably just guess that it's right. But your calculation gave 2 times that. So why is there an extra factor of 2 that maybe actually shouldn't be there? Well, it actually has to do with parity, right? We can't get to the origin because, well, if I get back to the origin, that means I have as many ups as I have downs and as many rights as I have lefts. But that would mean that I took an even number of steps, but I took an odd number of steps. So exactly half of the points in here are the wrong parity in some sense. And so that means that I can't get to them. But all the other ones I can get to. And so you take our final answer here and we divide it by 2, and then we do get the right answer. So
Yes.
it was lucky that,
Oh, good.
just
That's
2 times
okay.
this was
That's
not
really
one of the answer
helpful.
choices, because if it was one of the answer choices, that would be, I would have
I
chosen
would
it,
have
and
clicked
yeah.
that.
So we got lucky here,
Yes.
and we were able to catch that.
By the way, I know some people are asking what parity is. Parity is whether like a number is even or odd. So basically what Eli is saying here is that we can only get to points that have like the parity of the or I would say like the sum of the coordinates, the x and y coordinate has to be odd. And the reason why that is because we're taking an odd number of steps. And while some steps might cancel out, overall, you're never going to change 67 steps to some like even number of steps. Like you're always gonna have like some odd parity, and that's why like we're looking at the sum of the x and y coordinates for it to be odd. Meaning half of the points in here, like Eli said, don't work, and half of them do. So while everything up until the 67 squared times 2 part was correct, the key step here that we need to do is divide it by 2 because we can only reach half of those given an odd number of steps. Yeah, really, really great explanation, Eli. That was a really good catch.
And a very tough problem, but let's see if B is the right answer. It was not. Okay.
Oh dear.
Well, oh no. Oh no. Okay. Okay. So
Hmm.
they tricked us in 2 ways. This is interesting. Um, it's a larger answer. How could this
Oh,
possibly be?
oh. Do you think maybe it might be like we have to add the borders? But does
Oh,
that get
oh,
counted? I think we have to add the borders, right?
really? What is going
Because
on with the
not,
borders then?
I don't know. Because like not all of the points on the, wait, I don't know if that's going to cover enough though. Let's see, how much are we off by? 11, 24, 35. I think we're off by 135. Where are we going to get 135 from?
I mean, it's 2 times 67-ish, right? Uh, plus 1.
Yeah.
2 times
Oh, that
67
makes
plus 1.
okay. I think that makes sense because I think even Minghui says it's 68 squared. Ah,
Oh, yeah. Okay. 2 times 67 plus 1. That would indeed be 68 squared if you add it to 67 squared, because
yes.
that's 67 plus 1 squared. Why is it 68 squared? Wait, what's happening here? Uh, we take 67 steps. Is this not 67?
67. Wait, right? That's what I'm
What
thinking.
is going
Maybe
on
it's
here?
like no, that doesn't make any sense. Um,
Hmm.
that is wonky.
Okay, I'm confused here because I really think it should be 67 units across, right? I mean, I don't even think anything here is wrong. I think
Yeah, and I know some people are talking about the origin, but the origin shouldn't.
oh my God. It is that
Is
though,
it the origin?
because
Okay.
yeah, because you can get from 0 to 67 and there's 68 numbers there. I think
Oh, yeah.
it is the boundary. I think you're actually right, it is the boundary. It just so happens that you still get some
Yeah.
thing like this, maybe. Because yeah, I don't know. I mean, this is really weird. There are
I think
68 points here, and if you just do the area thing, it
yes.
would act as if there's 67. This is feeling so weird to me now. Uh, I don't know.
Okay, I want to look at maybe like a smaller example just to like double check the math here. So I'm gonna do like a 3 by 3 grid really quick, and show that on my screen.
Okay.
Let's see what that looks like. Okay, so we have 0 in the center. 1, 2, 3. 1, 2, 3. Okay, so if we go ahead and connect the dots here. Yeah, even if you can only take 3 steps, like the length should still be 3. Like the coordinates might be different, but okay, if we look at lattice points within here and we take half of them. So this answer should technically be 16. Let's see if that's correct. If we're looking at the case of 3. So I see in total Oh, oopsies. Did something wrong. Okay, no, I didn't. Haha. I'm, like, confusing myself now. I, like, don't trust myself. Okay. And there's, like, one point in here that I, like, missed somehow. Okay, my diagram is, like, not to scale. My apologies to whoever is maybe looking at the screen and is feeling a little confused by that. Okay, so in total, I count 1, 2, 3, 4. Oh, this is hard to count. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so I see 13 in the center bits. And then in pink, I've done... Oh gosh, I wanted to change that color. Okay, 13 plus. In pink, I've done 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, that doesn't add up at all. Huh. I'm definitely not getting the same answer. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 25. Okay. That's so weird. Oh my gosh. I feel like I'm being gaslit. Huh. That is so weird.
Now I'm even more confused because I tried to do it a different way. So I tried to just add up everything from the inside out. So like you can kind of like separate it as rings. So there's the
Yeah.
zero ring, there's one, and then like plus four is from the first step, right? A distance of one away. And
Yes.
then plus I think you get eight from the second one and then 12 and so on,
Yeah.
which should make sense. I think it's just kind of like four per quadrant or something.
Yeah,
Um,
yeah, yeah, yeah. That makes sense.
and so if you do that, I mean, you get 4 plus 8 all the way up to 4 times 67. So that's 4 times 1 all the way up to 67, which is 4 times 67 times 68 over 2, which is this. And then you divide that
67
by
times
2 for
68.
parity. And you get 67 times 68, which is not this number,
68 times
right?
68.
So
Okay, so where
now,
are we missing 68 whole points?
yeah, I guess there's also like a 1 in here. Oh, well, actually, is there a 1? I feel like my counting must be wrong. But like the first ring is definitely 4, right? The second ring is 1, 2, 3, 4, 5, 6, 7, 8. 1,
Should it
2,
be
3,
9?
4, 5, 6, 7, 8. No, it should be 8, right?
Is it 8?
1, 2, 3, 4, 5, 6, 7, 8.
Oh,
Yeah.
okay. Yeah, 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 it's 8.
Um,
Huh.
God, I don't know. Ah, people are saying to use Pick's theorem. I mean, I think that technically would work probably.
But,
Um,
like, we shouldn't need to use Pick's theorem on the AMC 8, I feel.
yeah. Okay. Things are challenging here. Maybe we could just move on from this problem unless we see something uh,
Yes.
else to do. Um, yeah, no, I'm not sure how to get a 68 squared answer, but we can come back to this at
Yes.
the
Let's
end
come back if we have
if we have
time.
the time. Oh, well, okay. We've lost our 100% win rate, but I guess it's okay. Uh, on
Okay,
to
let's look at 17. Hopefully, we'll
17.
regain our streak here. Okay, this is a short problem. What is the least common multiple of 1, 2, 3, 4, 5, 6, 7? Okay, I feel good because I know how to do this. I see a lot of people already putting in some answers, so let's double check. When we're looking for the least common multiple, we're trying to create like the the factors that like use all of the okay, hold on. I'm saying this really weird. So here's how I'm gonna do this. I don't care about one. Like every number is gonna be divisible by one. Now I can have like a number with two. Let's say my magic number is divisible by two. That's great. My magic number is also divisible by three. That's great too. Now, if my magic number that I'm trying to find is divisible by four, obviously it has to be divisible by two. So to be divisible by four, there has to be two factors of two. So instead of just 2, I'm going to do 2 squared, so that way I get that factor of 2 and the factor of 4. So that takes care of the first 4 numbers. Now 5 is prime, that's not going to come from anywhere except a 5. 6, luckily, is made up of 2 times 3, so I don't have to add another 6 here because I can already get a factor of 2 and a factor of 3. And then I have the last factor of 7, and so my final number should be 4 times 3 times 5 times 7, which comes out to be, I'm going to do 20 times 21, or 420 as our final answer. So answer choice number C. What I was trying to sorry, what I was trying to say initially is when we're looking for the least common multiple, we're trying to take the largest exponents of each prime number. So Eli has written on his screen the same values because in this case, all the largest exponents are 2 squared, 1 3, 1 5, and 1 7. There's no 2 cubes, no 3 squares, none of that. So these are the largest prime numbers that we are taking.
All right, I believe I agree with that answer. So let's see if the slides agree, and it looks like they do. So
Yes.
we've gotten this one right. We've made it past that devilish problem, and now we've gotten to something easier. Let's see if number 18 is also similar, but it looks like a long one. Okay. A hare named Zeno is racing against a tortoise named Aesop on a 128-meter course. Okay, 128 meters long. Great. Aesop runs at a constant speed of 1 meter per second. Zeno starts off at 8 meters per second until he reaches the halfway point, and then it's because, okay, this is the Zeno's paradox thing, uh, and so on. Yeah. So how many meters per second is Zeno traveling when Aesop finally reaches him? Okay, this is a fun little aside, but this is like how Zeno proved that motion is impossible because in order to get from one destination to another, you have to travel halfway and then halfway again and then so on. But you're doing an infinite process in a finite amount of time. But like math says it's okay, so it's okay. Um, okay, here we go. So let's see. The tortoise is going 1 meter per second forward, so it's just 1 meter per second here. And the hare here is doing this thing where it's going 8 first, and then 4, and then 2, and so on. So we're just trying to see when does the 1 catch up here. And I think we can set up an equation. Let's say that t seconds have passed. Okay, so t seconds. What is the distance that the tortoise has traveled? Well, it's just t times 1, right? Because it's 1 meter per second times t seconds. And how far has the hare traveled? Well, it gets kind of weird. We have to take however long it's been. I mean, assuming that it's been more than um, a certain number of seconds. Let's see, 128 divided by 8 seconds. Let's see, what is that?
16.
16. Assuming it's been more than 16 seconds, it's 16 times. Uh, well, I guess this doesn't even matter. I mean, it's just the distance. Oh, this is getting so weird. Um,
Well, I guess we could say like oh wait. Oh, that is okay, hold on. That is a little weird.
you have to like split
So,
it up into the first 16 seconds, and then
yeah.
what happens after that, and so on.
So like he travels okay, okay, hold on. We have to be really careful here. So, Aesop, let's say we're traveling like no, you know what? Let's go per second. So let's look at like how long it takes for Zeno to change his time. So like let's say we're at the initial 8 seconds, which is how long it takes Zeno to reach his first midpoint. So at the initial 8 seconds, we have Aesop, which I'm gonna say is A. This guy has traveled 8 meters, so that's 8m. Meters is m, and the hare has traveled 64. Okay, lovely. So now for the next, so now the hare travels at 4 meters per second, and he has 64 meters left. So he's going to travel another 8 seconds. So that's another 8 second interval. In that interval, Aesop is still going to travel 8 meters because his speed is a constant 1 meter per second. The hare, however, is going to travel 32 meters because that's half. Okay. And I think in maybe like an orange or something, I'll write the hare speed so that it's clear what that is. So meters per second and 4 meters per second. Okay, so now he travels 2 meters per second after this half point. And so that means for the next 8 seconds, because now there's only 32 meters left, this is really interesting. I think it's always 8 second intervals. So for the next 8 seconds, Aesop is again going to travel only 8 meters, and the hare is going to travel 16 meters now. And so I think like we're really looking at how long, like how many 8 second intervals we can kind of get through. Okay, so I think this will help us set up our equation again.
Yeah, okay. So we have to kind of just keep on splitting it up by the 8 seconds here. I was trying to think if there was a really clever way of doing this
There
with just a
probably
direct
is.
equation, but I could not see exactly what that is. And we know that it has to be 8 second intervals every time because the hair is speeding up as much as the distance is shrinking that it needs to go to speed up again, or slowing down as much as the distance is shrinking before it slows down again. So we are just looking at these 8 second intervals, and I think we could make a variable as to how many 8 second intervals have passed. Really, it's just going to
Yes.
be t over 8. Um, so actually, let's just keep it as t over 8. T is the number of seconds that have passed, and this is the number of intervals that have gone by. Maybe it's like the floor of this, but who cares? So t over 8 intervals have passed by. That means that the current speed of the hair is, uh, okay, 8 over t over 8 or something. Um, no, it's not that. What is it? It's just 8 over, yeah, it's the number of intervals. So it's 8 over t over 8. Oh, that's
Uh,
so weird, though.
Wait, is that the Aesop's speed or
The hair's
Z's
speed.
the hair speed? Um, Wait, let me double check what I. Wait, I think it should be. I don't think it's just that. Um, because let's say we get to the fourth interval. I think it should be two to the power of maybe.
2 to the power of,
Yeah, the number of intervals. That's yeah, that makes sense. Okay.
yeah, 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 yeah. Oh, yeah,
Yeah,
of
okay,
course,
okay,
of course,
perfect.
of course, of course. That, yeah, I don't know what I was thinking. Yeah, okay. It's just 8 times 2 to the minus t over 8. That's what I was thinking of, but couldn't quite say. So I think it's something like this. That's the current speed of the hair at this time. So t has to be equal to um, however much distance has already been covered, which is exactly uh, okay, however much distance will be covered after t over 8 of these intervals. The intervals are getting uh, smaller and smaller, so it's going to be like 64 all the way down, t over 8 times. So okay, this is so weird, but this is like 2 to the, well, this is 2 to the what? 1, 2, 4, 8, 16, 32, 64 is 2 to the sixth times descending sum. And so you could write this, okay, using some geometric series as, 1 minus 2 to the minus t over 8 minus 1 over 1 minus a half or something like this, I think. This is probably getting way too complicated. There must be an easier way.
I
Uh,
agree. I feel this is far too complex.
yeah, but this is, I think, the equation you end up getting. This is the distance that's already been covered, and then this is the distance that it's covered with this like extra bit, and then these have to be equal to each other, um, which is pretty terrible.
I'm not convinced this is the right way. Like, I feel like
I'm not
I
convinced
feel like
either.
we've got the right approach looking at the intervals, but I'm very hesitant that this is an equation we have to solve because this looks more like AMC 12 level if I'm being honest.
Yeah, I'm not even sure there is a nice solution to this. I think we may just have to go through the 8 second intervals
Yeah. Yeah, let's
and
let's do that actually.
just see when they pass each other.
Yeah.
But it may be after a
A while.
while. Because the answer choices are like 2 to the minus something, so uh, it could be like 20 steps later that they finally catch up. But okay.
Yeah. Hmm.
So that's fine.
Do you think maybe they like nah, that doesn't make sense. Huh. I never read. I thought I was onto something here.
Okay. I
Do you
mean,
want
there's
to
a
try
lot of t
bashing it
over
out
8s
maybe?
here. Yeah, I guess so. I don't know. I just feel like there's some equation here that could be really nice.
Yeah, I agree. I
Um,
think there's definitely a smarter way to do this. But for the sake of the problem, I am going to start bashing. Actually, for the sake of time, I'm going to start bashing. And if maybe you can find something a little sneakier while I'm doing that, we can try that. But I do want to make sure we can get an answer.
I hope we can. Let's see. Uh, So, okay, I'll just say what I'm thinking. I'm just going to get rid of t over 8 and say k is the number of steps that have happened. The distance that the tortoise has gone is 8k. We want to see when that exceeds the distance that has been gone by the other person, which we've said by the hair, which is 64 plus 32 um, plus 16 and so on, all the way down to however, whatever's left here, which is 64 times 2 to the minus k. Is that right? Let's see. If it's been
Oh,
one
you know what
step,
the
maybe
equation
it's
is, I
minus.
think? It's something like let's do like 8t is equal to um 60. Wait, what's the like 64 divided or like 64 times like 1 minus uh hold on, 1/2 to the power of t. It's like the sum of a finite geometric series
Yeah, yeah,
divided
yeah.
by
I mean,
one
that's
half.
that's
Okay.
exactly what I was having over
Okay, that's what
here.
you have. Okay, but
Yeah,
okay, I see, I see. Alrighty. Let me see if I can write, because like it's so clear to
yeah.
me that this pattern exists, but like
Mhm.
it's so ugly too. Like it's not a nice pattern.
I think the goal here is it's like the intersection of two curves, right? I mean, one of the curves is just this straight line, and then the other
Yeah.
curve is like this. And so we just have to see when they intersect. It's not actually like this, but it's like vaguely like this. And so it's going to take a long time though because this tortoise is going really fast, but then it's slowing down really gradually.
Yeah.
So, but eventually it has to hit the hare because, or the hare has to hit the tortoise because the hare is never even going to make it to the finish line, um, because
Yes.
it's always going to take 8 more seconds to go uh, the next billionth of a meter or something. Um,
Yeah. Oh, this is so sad. There's like so much potential for like a beautiful pattern and it just didn't happen.
uh, I think it is. I think this is right, and then you do this thing, and then magic happens, and
Yes.
um, you just have to find when this becomes bigger than this. And I really don't think there's even a better way than just plugging in numbers and seeing which side is bigger until you find where the change happens.
Yeah.
I don't know. I don't know if there's a better way. This just feels super cumbersome though. Uh,
Yes. Oh boy. That's sad.
uh,
Hmm.
it's okay. Um, yeah, let's just go for it. So this is, I think this equation is correct. So this geometric series will be 1 minus 2 to the minus k, probably minus 2, I guess, over 1 minus a half, and it's times 64. Being divided by a half is the same as being multiplied by 2, so this is 128 times 1 minus 2 to the minus k minus 2. And this is equal to 8k, and we just have to see when this happens. Well, we want to see when k is bigger than whatever this is, divided by 8. So let's see, 64, 32, 16, I think, um, times 1 minus 2 to the minus k minus 2. I don't know. This is just annoying. I mean, we can just plug in like k equals 10 and see what happens. When k equals 10, this is 16 times like, oh, well, actually, what am I even thinking? This is always going to be like around 16. So when
Yeah.
k equals 17, I think it's as simple as that. Or when k equals 16. Oh my God. I think you just plug in k equals 16 and it has to work because 16 of course is bigger than 16 times some smaller thing. Um, right? And so when k equals
Yes.
15, this is not going to be true because this is going to be really, really close to
To
16.
six. Yeah.
But when k equals 16, oh my God, I don't know what I'm thinking. But okay, I think k equals 16 is fine. So t would be 8 times that, or around 8 times that. And so you get 128. Okay, so around 128 seconds. Let's see. Um, we want to know, oh, well, that's not even what they asked. We want to know how many meters per second is traveling. Oh, and there's answers that are one apart. Why do you have to do this to me? Okay,
Wait,
so
so wouldn't it just be 8 divided by like 2 to the power 16?
Um, yeah, or like 128 is this. Oh, yeah. The starting speed is 8. Yeah, you're right. So it's 8 divided by 2 to the 16.
Yes.
Yeah, which is 2 to the minus 13. Okay, so it's either this or 2 to the minus 12. I mean,
Something close.
oh God. Okay.
I
Um,
really feel like there's gotta be a more clever solution here.
okay, well, it happens in between 15 and 16. So actually, I think it's 2 to the minus 12. Because I think it's 2 to the 15 in the bottom because it's still at the
Okay.
15th step when they intersect.
Yeah.
And at the 16th step, the tortoise has already passed the hare.
Okay.
Okay, I think it's actually 15. I think this is all a trick. And so then this would be negative 12 is how fast it's going. And so I believe the answer should be D. If it's E, I'll be really sad. But I just got to check.
I think I like D.
Okay, okay. We
Yay!
made it.
You wow, you powered through, Eli. That was amazing.
Yay. Okay. Uh, on to the next question. Sam, you can take it away. This is probably the last one we'll do, unfortunately.
Alrighty, let's take a look. Okay, so we have an urn with 3 blue balls and 2 red balls, which are otherwise identical. And you can pick one of them uniformly at random. Whatever color you get, you put that ball back, plus 1 new identical ball of that same color. And so basically, every time you're picking a ball, you add an extra ball back. So you repeat this process one more time until you have 7 balls. And we want to figure out what is the probability that is blue. So I think the best way to do this is probably some casework. Since we're running a little short on time, I'm going to go ahead and do this super duper quick. So my first case is, let's say I got a red ball. Let me go ahead and put a phone. Okay, here we go. So let's say I got a red ball initially. Then I have a probability of, let's see, 2/5 of picking that first red ball. And then I can actually go into 2 different cases here. So let me go ahead and like split off again. So the next, or actually, yeah, okay. So the next case is like, let's say at this point, like once I've picked my first red ball, back the I'm adding back another red ball. So I have 3 blue, and 3 reds. So the second case is like, what if I pick a red ball again? So if I pick a second red ball, the probability of that happening is 3/6. And now I'm left with maybe picking my last ball, and I want that to be blue. So that'll be 3/7 because remember I've added a blue ball. So this last one we want to be blue. Okay, the second case is like, what if the ball I pick when there's 6 balls in the urn is blue? If that's the case, that happens with 3/6 probability. The probability of picking a blue ball with 7 balls in the urn is going to be 4/7. And so if we go ahead and multiply all of the, well, actually, I guess we'll do that at the end. Okay, so that's the first case. The first case, like we pick red. The second case, we pick blue as our first ball. And if that's the case, that happens with 3/5 probability. And so in that case, we once again have to split off into more cases. So let's say we pick blue. This next case is we pick red for our like when we have 6 balls. So the probability of that happening is going to be 2/6 because remember we added an extra blue ball but not a red ball. And then the probability of picking blue in that case should just be 3/7. Oh, actually 4/7. My bad. 4/7. Okay, lovely. And then the second case is we pick blue. So that happens with 4/6 probability, and then blue for the last ball when there's when there's 7 balls in the urn is going to be 5/7. So basically, we just go ahead and multiply all of these things out. So starting off, 2/5 times 3/6 times 3/7 is going to be, I'm just going to do the numerator and the denominator separately. So 2 times 3 times 3 is going to be 18/5 times 6 times 7. And then 2 times 3 times 4 is 24/5 times 6 times 7. And then 3 times 2 times 4 is 24/5 times 6 times 7. And then 5 times 4 times 5 is 100. Is it? Oh, wait. Haha, I messed up. 3 times 4 times 5 is 60/5 times 6 times 7. Okay, so adding up all my numerators, 18 plus 24 plus 24 plus 60 divided by 5 times 6 times 7. Okay, so 24 or 18 plus 24, that's going to be 42. Plus 24 is 66. Did I do that right? Yeah, 66 plus 60 is 126 divided by 5 times 6 times 7. So if I go ahead and simplify, I should get 3 over 5? Wow, for such a simple answer, all that work. Maybe there's a smarter way. I don't know. 3 over 5. Aha, that is correct. Yay! Okay, and right in time. All right, I think we have like 10 seconds maybe. Okay, well, we apologize for not getting through all of the problems, but we hope that for the ones that we did get through, you guys learned something new and you had a lot of fun. Thank you all so much for joining us, and we hope you liked the live way of teaching. Eli, do you want to add anything?
No, I don't think I do. Thank you all for coming. Again, we had some struggles, but that just shows that this was a really well-written AMC 8 mock test, maybe a little bit harder than usual AMC 8s, I don't know. But hopefully it was a lot of fun for you to take or for you to watch us try to struggle through. And for all the other problems, feel free to try them at home and see if you can solve them, the ones that we didn't get to. Okay. Bye, everyone. Thanks for coming.
Alrighty, bye!